Okay, for this question we have another counting problem, and it's a little bit longer, so I'll pull out the highlighter. So consider a message source that generates the 0, 1 symbols. Okay, so we have something that generates 0 and 1. How many different messages of length m, okay, can be generated by the source? Okay, so how many different messages of length m can be generated by the source? Let's see. So let's look at question 1. Okay, I have a source that generates things from the alphabet 0, 1, right? How many different messages can I make of that alphabet would be the number of permutations of that alphabet, right? So if I have, let's say, 2 bits to work with, right? I have the set 0, 1 as my alphabet, and I have, let's say, 1 position of that. I would have 2 to the 1 options for that message. If I add another position, I again have 0, 1. So I had 2 to the 2, which then means at infinity I would have 2 to the length of the message, different options. And I guess that's all there is to it, right? If I have the alphabet of 0 or 1 and I have m positions, I have the length of the alphabet, which is 2, to the power of the size of the message, and that's just because we're looking for how many ways to permute that set of numbers, right? Okay, or I guess I should say that collection of numbers. So now let's look at part 2. I guess this one was simple enough. Am I in the camera? I'm in the camera. Okay, part 2. How many among messages of length m, so among and m, have k or more ones? Okay, so let's think about this as a counting problem. So let's look at 4 of these. If I have 1, 0, 0, 0. Okay, let's see. So I would have here one such configuration of having 1, 1. I can also have this one. I can also have this one. Right? And then, of course, these are all unique zeros. So essentially, simply put, if I have m length of message and I have k number of ones, I have m choose k 1 symbols, but I want 1 or more. So then I would also have m choose k plus 1 plus m choose k plus 2 plus ... Okay, pretty simple, right? Consequently, I also have 1, I can, do the contrapositive, right? How many messages? So I would have, well, let's look at the contrapositive when we get to part 3, when we look at the, actually let's not confuse the problem, but essentially I could also have m, well, I could have the opposite, right? I could have the total number of messages minus all of the ones less than this, but I don't want to really write that out. Let's just look at it this way, right? Start with k plus 1, k plus 2, k plus m, right? Or k plus whatever value gets me to k plus that value equals m. So let's look at question 3 now, which has a star, which means it should be a little bit harder. So consider a message source that generates the 0 symbol with probability 0.8. And the 1 symbol with probability 0.1. With what probability does the source generate the sequence 1, 1, 1, 1, 1, 1, 1, 1, 1, 1? Okay, so first question, how many 1s do I have? I have 1, 2, 3, 4, 5, 6, 7, 8, 9 1s. So my length is 9. Okay, so let's do this the easy way. 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. So I'm looking for the sequence, all of those to be 1. I generate the 1 with probability 0.1. So what goes into this one? If it's a 1, it would be 0.1 multiplied by... Oh, this is an error. I have an old version here. Of course this can't be 0.1 and that can't be 0.8 because they need to add to 1. So let's call this 0.2. Right. Okay. Sorry, I have an old version of the assignment with a typo. So it has to be 0.2 times or 1, yeah, minus 0.2, right? 0.8. Let's put it like this. 1 minus 0.2. No. I goofed that part. Okay. Ignore that. Whoopsie daisy. Okay. So this is 0.2, 0.2, 0.2, 0.2. La-di-da-di-da-di-da. Right? So essentially what I have here would be 9, choose 9 ones with a probability of 0.2 to the 9, 1 minus 0.2 to the 0. So 9 choose 9 is 1, and then yeah, so 0.2 to the 9. Yeah, so there you have it, right? Okay, 0.2 is 1 over 5, so this is equally correct. Essentially, you treat each one of these positions like its own experiment, right? And then thus it would be Bernoulli distributed, right? But I mean, ultimately, it's just the probability of each position. There's only one such configuration for this because every permutation of it is itself. So that's why this is 1. This is 0 because there are no zeros. So, okay. Or rather, the exponent is 0, not the probability. But yeah, that's the end of that problem. So now let's take a look at question number 4. I noticed that a lot of students get really bothered by this idea of a parameter epsilon. Epsilon is just a tolerance. So epsilon is some value, and we say less than 1 or equal to 1, and greater than or equal to 0. Right? This way, it exists somewhere inside the closed interval 0, 1, which is our probability space. So, with what probability that the source in item 3 above will generate a message with at least k symbols? Item 3 above is 1 is less than epsilon. Show with a formula how we choose the length of m of the message. Okay. So, how do we do this one? Let's take a look. What's the easy way to say this? So, what we have here is essentially I'm going to use a fresh piece of paper. Okay. I guess what we meant here is this generator with length m. So, okay. I need to get a probability of this whole system happening. So, I need the probability of at least k symbols being 1. So that's m choose k plus m choose k plus 1. It's the thing that we solved previously. So plus m choose m. Now I need to divide this by the entire size of that set. So the entire size of that set would be, let's see, okay, so if we go back to here, we have this 0.2 as opposed to 0.1, so that 0.2 with length 9, like I'm trying to make this problem seem related, because it's you just take part 2 and part 3 and divide, right? So, okay. So really this would be the number of k's, right? If you think about it, you divide by the number of k's that you would have. I guess over here this would be the same thing as, well, let's divide by 5 to the k, right? Because I'd have 1/5 less than epsilon. Let's see, does that make sense? Because I would multiply this by the probability, right? Let's see. It's been a while since I've looked at this problem, and I want to take this and do the whole problem in one take. I might have to do it again. We'll see. At least k symbols 1 minus epsilon. Okay. Greater than 0. We want the probability that the source in item 3 above. Okay, I think it's the number of this over 2 to the m. Okay, so there are 2 to the m possible messages. This is the number that have ones, at least k ones, and we want to find the probability that the source in item 3 generates a message with k symbols of 1 less than epsilon. So okay, this would be a 2 to the m. Okay, and that's it. That's the end. Okay, a little bit of a stagger there, but we got through it. It's kind of a tough problem. It's one of those difficult counting problems. So I'll see you in the next video for question number 10. Bye.